numerical number 1.
So electromagnetic radiations, what is the effect of
Numerical number
radiations?
1.
What is mean by
Already
the
we have done the
radiations? We
1,
will see
2,
here.
3, 4,
The
and the
radiation
5
is by
in
the
the
definition,
previous
if you see what
lecture.
is mean
Today
by
we
the
will
radiation.
continue
So
the
you will be
numerical
able to
numbers
observe
that is
the radiation
6,
is
7,
an
8.
energy in the form of your the electromagnetic waves or the particulate matter traveling in the air. Okay, so in short, you can say these are nothing but the waves,
So
electromagnetic
what is that?
waves,
A copper
and
got
that are
rectangular cavity
traveling, okay, or percolate, okay, in the air. Okay, fine. So that is nothing but
So
your
what
the
is that? A
radiations.
copper
If you
walled
observe the
rectangular cavity
day-to-day
resonant
life
is
or the daily
structured by
routines,
a
you will be
3
able to
1 4
observe that
centimeter
there
and
are
operates at
various
the dominant mode
radiations.
of the
Okay,
TE
so
and the
the
TL.
radiations are
Find
of
its
various types,
resonant
or
frequency
you
and the
can say the
quality factor,
classification of
comma.
the
The
radiations.
conductivity of
There
the
are
copper is
various
5.8
examples
into 10 to the
of
power
the
7 watt per
radiations.
meter.
So in the
So if
day-to-day
there
life, so
is
in short,
air
you can
inside
say
the cavity, what will
they
happen? So
are
here
dependent
how we can
upon
start?
the
The important thing is
electromagnetic
that
radiations, and the examples
name
which
of the
are
waveguide is
related to the
nothing but the
radiations
rectangular
are
waveguide,
nothing but your
and
the
that too at resonant
photosynthesis
we need to
and the
calculate the
regions
quality
of your
factor as well
sunlight,
as the resonant
ultraviolet
frequency.
light are also there. The what we can say the gamma rays, the alpha, beta, gamma rays are also there. There are tremendous application related to the electromagnetic radiation. Okay, but the question arises here, how that radiation occurs, what is the basic concept behind that? Okay, what is the use in that radiation in the electromagnetics, or you can say in the antennas? There are various applications, but we are interested. The use of the radiation is in the form of the electromagnetics, or you can say in the antenna. Okay, even though we are having a tremendous application, but we are focusing on particular application, that is nothing but the role of radiation in antennas or role of radiation in electromagnetics. So what are the basic concept related to that? The basic concept related to that, how the energy will be transmitted, how the energy will be created, what is mean by that energy. So we know very well the energy is nothing but the ability to do the work, and we know very well how the work done or how the work energy will be transferred from the one body to the other body, that takes place from the one place to the another place. That is possible. Okay, how it is possible, how they are transferring, what are the ways of transferring that energy from the one place to the another place, that is important. So that we are interested here. The three things are very important while the energy is generating, or the energy is forming, that is nothing but the conduction, the convections, and the radiation. So if you talk about the conduction, definitely this conduction is nothing but the occurs when the one body uh, collides with the other. And what we are saying to collide, that is nothing but whenever there is a occurrence of the conduction, is nothing but it will be occur in a one of the particular body. If we are considering treating a body, definitely it will be the atom or the molecules. Okay. Secondly, the convection is nothing but the energy is transferred from the one place to the another place by the physical moving the bodies. Okay. It means transformation is happened in the convention, not in the conduction. Okay. Third is nothing but radiation. It's only the form of energy transfer that can takes place in the vacuum, such as a region when the sun and the other earth, they are taking the example, whenever the radiations are going on, whenever the transformations are going on, that is possible with the help of the sun rays. So by the definition, that is electromagnetic radiation, so that consists of the self-sustaining, the oscillating electric as well as the magnetic fields. Because every time we are, so from the beginning we are learning EM, that is electric as well as the magnetic field. So we are talking about combinedly the electric and magnetic field. So similarly, this radiation, the example or the application related to the electromagnetics is important here. So in this field, this oscillating the electric as well as the magnetic field at the right angles, okay, to each other. We know very well they are perpendicular to each other. If one pass in the horizontal, the other will be the vertical, that is nothing but perpendicular to that one. That in this way they are going to propagate. So that is electric and magnetic waves are propagating. It does not require the supporting medium and the travels through the empty space at the speed of light. Obviously, that also we are aware. That's why the most widely applicable, the application is nothing but the free space. We are talking about the electromagnetic field in the free space. Okay. So in short, they are not requiring, what is the reason behind that? They are not requiring any supporting medium, okay? Whenever they are traveling, whenever they are transferring the energy. So in short, the electromagnetic radiation is the form of the energy emitted and absorbed by the charged particles, which exhibits the wave like behave as it's traveling through, and it propagates with the wave motion that at a particular velocity of your the light, that is nothing but your the t into 10 3 into 10 to the power 8 meter per second. So these are the basic concept, that is nothing but if we are learning the electromagnetics, that to radiation, electromagnetic radiation. So definitely these are transferring, but they are propagating, transferring the energy, okay, and that in the form of the wave propagation with the velocity of the light. So again, the electromagnetic radiation, which is nothing but the production of electromagnetic radiation and its propagation through the space, and its interaction with the matter is explained by using the various laws are applicable here, by which with the help of that we can identify, we can find, we can use in many of the application this radiation word. So in the radiation in the antennas, the radiation in the towers, radiation in the sun, there are a lot of applications are there that we will see soon. So what is that wave model? So the scientist Maxwell's conceptual EMR, that is nothing but electromagnetic radiation in 1960 century, the electromagnetic energy or the wave that travels through the space at the speed of the light is what we can say the explanation of the concept will be declared by that Maxwell's in that 1860. Okay, and we are aware that the speed of the light is nothing but 3 into 10 to the power 8 meter per second, and this electromagnetic wave consists of the two uh, fluctuating fields. So one is electric as well as the other is nothing but the magnetic field, that we are aware. The two fields are at a right angle to each other, or you can say they are perpendicular to each other to the direction of propagation of your the wave. So see here the wave, how they are traveling. See here, one how they are in the what you can say, the one is in the vertical, one is in the horizontal, how they are slanting, how they are propagating like this in the blue, and the this pink way they are, how they are traveling. In this we are finding one will be treated as electric, that is the pink is treated as electric, so other blue is treated as a magnetic field, and the length between these two, in that the magnetic as well as the electric both are we are concentrating. See here the middle or the center part of this view, and see here this middle part. So definitely these two are acting in that, and the length which we are interested to find out in the EM is nothing but the wavelength. Okay. So the parameters which are already we have studied about the basic concept related to the electromagnetic, that is nothing but which parameter will be affected. Okay, that are how they are characterized in the wave motion, or the when the wave will be propagated in the particular direction. So that which things are important here, the amplitude, the wavelength, and the frequency matters here, along with your the propagations. Okay, and if you're talking of propagation, then the attenuation and the phase constant also come here. So here in short, you just remember the amplitude is matter, how we can find that amplitude. This mentioned here the peak value of your the sine waves. Okay, how that highest or the peak wave we can get it, and how we can find that sinusoidal wave of this one, that is nothing but the one cycle is nothing but the lambda. So this is nothing but the distance between the two corresponding points. If I'm taking this at a center of this one, so it will be go out with the other center of this one, like the complete the one sinusoidal waveform is going to, and it is measured in the meters. Similarly, we should know about the frequency also, the number of cycles of a wave which is passing from the fixed point to the per point, you can say, with respect to the time period. So that is measured in the hertz, and we know very well the frequency is the per cycle number of per cycle. So that is nothing but F is equals to 1 by T, and it's measured in the hertz, kilohertz, megahertz, gigahertz, likewise. So in this way, these basic concepts are very important to learn about or to know about the radiation, how the things are coming, which are the basic concepts related, because we are learning that radiation in the electromagnetics. So especially we are talking about the in the electromagnetic. That is too important here. How we can find that lambda, how the lambda is changing, whether I want to measure it at the initial stage, whether I want to measure in the middle stage, whether I want to measure at the final stage. That also lambda 1, lambda 2, lambda 3. Likewise, you can find all the wavelength in at every instant, or you can say the at a particular step by step you can find that lambda. Okay, so this wavelength of a one complete wave cycle, and it can be measured at a distance between the two successive. And the, what is mean by the crest is nothing but it is a point on a wave with a greatest positive value or upward displacement in a cycle. Okay, and that I will show you what is mean by that crease with the help of the figure in the further slides. So what is mean by throughput or the throw is nothing but the inverse of the crease. So if it is a maximum or greatest positive, it will be the reverse one, that is nothing but the negative one. If you observe this figure diagram, you will be able to observe here how the transverse wave. Already we know, we are aware that is the transverse waves are available in the TE or TM or the TM. That is nothing but transverse of electric field wave or the field, transfers of magnetic wave or the field, or the transfers of your the electric and the magnetic wave of the fields. So in this way, we can observe easily the sinusoidal on the sinusoidal waveform, which is the amplitude. See here, each and everything is mentioned clearly. See here the amplitude form. See, this is the amplitude here, but we are aware, if theoretically we are talking, we are considering assuming only the one sinusoidal, but it is not practically happening. So multiple sinusoidal waves are coming simultaneously on the each instant. Okay, so if here infinite sinusoids are coming, the maximum is nothing but that level is nothing but that crest. Okay, so here this middle, this mid and this mid is nothing but your the wavelength, and this negate because it's opposite to the crest. Crest is the maximum or the greatest positive peak. Okay, and throughput is the opposite to vice versa of your the crest, and direction which is showing in the right direction is nothing but the direction of the travel or the direction of propagation or the wave propagation, you can say. And this portion is here movement of a water molecules, with how the changes are going on every time in the sinusoidal waveform, that also we can observe. So crest is nothing but the point on a wave with the maximum value or the upward displacement within the cycle. And throw is nothing but the opposite of the crest. So it's a minimum or the lowest point in the cycle. So see here the difference. Here the example is given, how this is the crest, how this one is the throw. Okay, so many times in the calculation also we need to take care how we can calculate the crest, how we can calculate the throw. So general properties, you can say we should remember while we are learning about the electromagnetic radiations. So in the electromagnetic radiations, that can be traveled through the empty space, or the most other types of the wave must travel through the sum of the sort of the substance. The examples are given in the radiation of your electromagnetic is the sound waves. Need either the gas or the solid or the liquid passes through in order to be a we need to heard it. Okay, so the speed of the light always a constant, that we are aware. Okay, and the wavelength are measured between the distance of the either the crest or the through, because it may be sometimes the maximum or the greatest or the peak, or it may be of a minimum or the lowest. Okay, so that we every time we need to take care, we need to find out the crest as well as the throw. So that is nothing but in the form of your the ultimate. If you are talking about these two, means you are talking about the wavelength, and that is denoted by the lambda. How to that electromagnetic waves will be different. Okay, so we know very well the electromagnetic waves carries a different amount of the energy. This is the one of the example. We have a tremendous examples of the electromagnetic, but we are talking about one of the examples here, that is nothing but the microwave one or the microwaves, which carries a less energy that in the as compared to the X-ray. If you talk about the X-ray, the energy will be the different. If you talk about the other example, that will be different. So in each and every cases, already we are aware from the spectrum, electromagnetic spectrum, in that we can observe depending upon the wavelength, frequency, and the applications of related to the electromagnetics. The amount of energy carried by the electromagnetic waves depend upon the wavelength. Obviously, that we are aware, okay, how they are traveling, which is the peak, which is the mean, which is the greatest and the lowest value. So shortest wavelength and the higher. What is the conclusion behind this one is, while we are talking about the wavelength, that is the shortest the wavelength, definitely the higher it's the energy. So wavelength and the frequency are linked properties of the wave. The shorter the wavelength, the higher its frequency. See here, greater the energy as well as the higher its frequency if the wave is shorter. So the frequencies also tell us about the energy of the wave. Higher its frequency, the higher is the energy in short. So this is also one of the examples of what happened when the waves hit a surface. Okay, what will happen? So one of the examples is mentioned here. When the electromagnetic wave hit a surface, they can be reflected, absorbed, transmitted. That we are learned reflected, reflection, and all. Reflected, absorbed, and the transmitted. The wave behaves depending upon their energy and the type of material which is used. Example, the light waves are reflected by the skin, okay, but X-rays passes straight through. So if electromagnetics are absorbed, some of their energy will be absorbed by the material and usually increases the temperature of that material, that we are aware. These are the two examples. Okay. So particles model, one of the model wave model, second model is nothing but the particle models. In the electromagnetic energy may also be described in the in terms of the joules and the electron volts. The rate of transfers of energy from the one place to the another place can be find. We can find the fluxes energies, how the sun rays are passing from the sun to the earth. That also in the physical that we observe, how the flux must flow and it measures. Okay, how the light spectrum, how the particles are going on, how the photons are coming, each and everything we need to concentrate while we are learning this subject. So when the matter excited thermally or the nuclearly, when we are talking about the radiation, even though we are talking about in terms of the electromagnetic, so we should aware from this the basic concept. Okay, photons, how the photons moves, how the speed of that, how the photon is exits or exits or reflected and absorbed the radiation, how the amount of the energy is associated with the photon can be determined. The Q is equals to HV. Okay, where the H is nothing but the Planck constant that we already we know the basic concept. 6.62 is the constant value into 10 from 34. So
We
in
will
this way,
see the
with the basic
numerical
concept
on
related
the
to the
rectangular
radiation we have studied. Now
as well
come
as
towards
the
the point
circular
that is nothing but the
waveguides.
types of
Already we have
radiation. Two types
studied
of
and learned
radiations are there.
about
One
the
is known as
theoretical part related to the
ionizing
rectangular
radiation,
as well
another
as the
is known as
circular
a
waveguide.
non-ionizing radiation. These are the two types of
We
the
will see
radiation.
the
What is
numerical
meant by
on the
ionizing and
rectangular
non-ionizing or
as well as the
non-ionizing
circular
radiation
waveguides.
differ from the
Already we have
ionizing
studied
radiation
and
like
learned
the way they
about the
act
theoretical
matters
part
like
related to the
air,
rectangular
water,
as well
living
as the
tissues.
circular
Okay,
waveguide.
unlike the X-rays and other the other forms, gamma rays, X-rays are nothing but the non-ionizing. So practical radiation from the radioactive decades are nothing but the ionizing. Similarly,
By substituting how we
ionizing
can calculate the
radiations are
velocity
higher energy
propagation 1 by root
electromagnetic
of mu
waves,
0
that is the
epsilon 0
gamma,
3
or the
into 10
heavy
raised to the power
particles,
8
that is beta
meter per
and alpha,
second.
may
If
be
I am
there
going
in the
to substitute the value
ionized
of your the mu 0
high
epsilon
enough
0, that is
energy
a
to
4
pull
pi into
the
10 raised to the power
to
minus
get the
7 and
electrons from the
8.854
orbit.
10 raised to the power
Similarly, in
minus
the
12. If you
non
are
is
going
nothing
to
but
substitute
lower
in the root,
energy in the
definitely you will get the
electromagnetic
answer 3
waves,
into 10 raised to the power 8. Whereas the
we
dimension values I
get
really and the p 3
from the
centimeter 1
non-ionizing
centimeter
terms, and
need
the
to
non
convert
enough
into the
energy to
meter,
pull
that is a
the
0.03
electron from
meter
the
and
orbit, but
0.01
only
meter.
exits the
Substitute
electron. So these are the two differences. So the alpha, gamma, beta are nothing but the ionizing term, and but that gives a higher energy, whereas the other gives the non-ionizing, but they are having a lower energy. If you observe this electromagnetic spectrum, you will be able to find what are the ionizing radiations here. So alpha, beta, gamma, we see here from the visibility, that is ultraviolet, the X-rays, the gamma rays, the cosmic rays are nothing but the ionizing radiation. Whereas the non-ionizing, that is a radar, FM, TV, short waves, broadcast, and the power transmissions are nothing but the non-ionizing. So in this way, you can find out the wavelength in the meters. You can find the energy. You can find the lowest and highest energy in the energy electrons. Okay, spectrum. So in this way, non-ionizing radiation sources are nothing but ultraviolet light, visible light, infrared, microwaves, radios, televisions, and power transmissions. Whereas ionizing radiations are, by the definition, if you observe, these are nothing but capable of producing the ions when they're interacting with the matters. In other words, enough energy to remove the electrons from the atom is nothing but the ionization process. The sources which are coming for the ionizing in the X-rays, the radioactive, the material produced in the alpha, beta, gamma radiation and cosmic from the sun and the space. So in this way, these are the examples of your this sun rays, how they are falling on the earth, what is the effect on each and everything in the atmosphere, and other thing that is mentioned. Similarly, the sun rays, how the sun rays are passing and what will be the effect of that, the temperature of that, the absorption of that, each and everything, how they are coming upward and downward, that is mentioned here. Similarly, the non-ionizing examples, how the radiations are coming, what are the sources of radiation, if the man-made and another thing that is mentioned here. So what is the effect of that? That is nothing but in terms of the radio frequency range is 10 kilohertz to 300 gigahertz. The effect only to possible at 10 times the permissible exposure. Okay, heating of the body, contracts, some studies how to effect can be observed. Okay, so radiation, how we can control that radiation, that is in the form of two things, monitoring as well as the controlling. The basic controlling method with the help of the external radiation is nothing but by decreasing the time, by increasing the distance, by increasing the shielding type. So in this way we can find what is the, how in this way we can control the radiation. Okay, so how we can control the radiation in the form of the time, distance, and the shielding. So time can be minimized. So minimizing the time of the export to minimize the total dose. So the rotate or the employs to the restrict the individual doses. Similarly, the distance minimizing to source to minimize the attenuation in the air. The effect of the distance can be estimated from the equations. Okay, similarly, shielding minimizing is the exposure by placing the absorbing the shield between the worker and the sources. So in this way, we can find each everything. The monitoring the personal dosimeter, with the help of that also we can monitor. We can monitor the what we can say the thermomolecules, the detectors. In this way, we can find all types of radiations. Okay. Similarly, how we can go for the radiation mechanism. We know very well that the charges are transmitted over the straight metals. So here the three way the if conductor is there. So if you observe this case, so you will be able to find there is no radiation. Why? Because the same amount of speed do not produce the radiation. See, the constant speed do not produce the radiation. If they are going in the same way, the same speed or the same value, so they are not going to produce any kind of radiation. If the charge is encountered, the discontinuity OC, when and the speed is changes, there is a radiation, definitely positive, negative, or the variation in the speeds. See here the wave. So at that time, we can say the radiation will happen. How we can get the higher or highest the radiation, that is in the resonant structure or the circuitry, the charges continuously oscillate and creating the continuous stream of the radiation. So that is nothing but where the highest radiations occurs wherever there is a discontinuity, whenever there is a resonance is occurring. In such cases, the highest resonance can be occurred. If you take the example of your the transmission line, and if you talk about the transmission line, definitely two wires will come in our will come in the picture. That is, the two wires are connected, and the load is connected at the end side. The source will be at the source, that is at the beginning side, initial side will be the source, the terminating side will be the load, and in this way in the transmission line two wires are passing. So in such a case, how we can write the expression for that two wire line closed on the load, or how the superposition of an incidence and reflected wave can be happened. Already we have written such type of, we have learned and studied such type of expression, that I of apostrophe x is equals to capital A is the vector A and the B are the two vectors, and this is the exponential expression A dot of e raised to the power minus j beta x. Similarly, b e raised to the power j beta x. So likewise, the resonatory line is nothing but the line with an open circuited or a stationary low. Every time on a particular instant, at any particular instant, maybe here, maybe here, maybe here, if a circuit is open circuitry and the resonant, if happens, so how that can be calculated. So that is possible with the help of the exponential or mathematical expression, that is I of particular x, that is at a particular distance, what will be the current I. So this is the receiving current, that is IR plus e raised to the what you can say the complex exponential form of your the expression, that is nothing but the propagation constant and the other parameters. This is the receiving point, and here also the coordinates of y with respect to the time period t. Concentrate. Similarly, see here it changes. If bended y, see here this is the bended y, this is the bended. What it will be the effects? The classical exponential concentration arm of the lines are moved away, and the current distribution remains the same. So in short, you can say the amount of the current which is flowing through will be the same, but see here the differences is going, how they are moving ahead, how the radiating dipoles will be there. See here two straight line of a same angle of a same distances, okay, which is from here. This pole is nothing but the radiating dipole. So when we have in phase currents for the effective radiation, the principle of the dipole antenna will come into the picture. In practice, there is a mismatch. Then we see the resonant antenna. So see here, this dipole source is connected to the transmission line of that, and these two poles are nothing but matching. So at that time, you can say that radiation dipoles are going on. So in such a case, where we know the basic concept as epsilon is equals to, if we are writing in terms of the real and the imaginary, so epsilon dash minus 0 of epsilon double dash. You can find mu is equals to mu dash minus mu, 0 of mu. Likewise, you can find easily the complex electrical permittivity and permeability and the conductivity sigma also for studying the electromagnetic propagation of medium or the radiation. So in this way, the radiation sources are nothing but the current and the charges present in the medium are called the primary sources. So in that primary sources, the surface current density denoted by the IP, that is amperes per meter square. Surface current density IP, volume charge density QP. So in this way, the other sources are electromagnetic fields are E and the H, where the E is the volt per meter, I is nothing but amperes per, H is nothing but amperes per meter. So the current and the charges can be measured, that is IC and the QC can be measured easily. So Maxwell's equations again plays a very vital role here. Already we are aware from the uniform plane wave, the wave propagation and other parameters. Whenever we have studied about that topics, the Maxwell's equation come in the picture. So here the equation how we can write the root of E, that is minus mu of dou H by dou T, that is the magnetic field. So conductivity and other parameter. We can write here the expression for conductivity, expression for permeability, charge densities like the source can be distributed linear surface on the volume density. That we know the sinusoidal sources are also there, that is a homogeneous and isotropic. So how we can find the electric in the either in the root or the mod, you can take anything. You can take that is minus j omega mu h. Already we have simplified such numerical conductivity into E plus j of omega epsilon E. When we are talking about magnetic field, that will be the zero. Divergence of D and the divergence of B will be the zero, and D will be the QC, that is nothing but with respect to the charge. Similarly, the relations of the surface of the radiation, that is E and S, that is nothing but epsilon 1, epsilon 2, mu 0, mu 1, conductivity 1. Likewise, you can find easily. So in this way, the N is a number of views you can take here with concentrating the tangential of the normal N. And you can see here, if we are having only one medium, then 1 will be there. If I have a 2, then the 2 you need to take. The electric field is there, then tangential and normal form will be there. In this way, the electric and magnetic field can be found in terms of the charge and the current. The EM potentials are also there, how the divergence of V can be calculated with respect to the T and other, how the vectors will come, how the electric field with the radius and the time can be calculated, that is mentioned here. So in this way, the expression of Maxwell equation based upon the potential in the form of the expression, that is a del square V into minus mu epsilon dou square V by dou T square is equals to minus Q by epsilon del square A minus mu epsilon dou square A by dou T square is equals to mu I. Likewise, you can find all the expression even in the vector potentials also. V is equals to 1 by 4 pi epsilon 0 integral of L of length, that is Q into R. So that also possible to calculate. Explanatory form related to the hertz, what you can say, this is one of the law or the dipole to calculate the dipole length, that is possible. How the charges are coming plus and minus. If dipole we are talking the upper plus and bottom minus charges, we need to find out at a particular from the particular distance, that will be divided into the two sections for positive charge and negative charge, and this is nothing but the incremental or the distance, and this way you can find at a particular point what will be my R0, what will be my resultant R, what will be my R1. So this will be the difference between the R0 and the R1 is nothing but the R, and this is nothing but the theta. In this way, you can find, calculate the electric field with respect to the R, and these are the point and the Z in the Z direction. So these are the charges and the currents is mentioned here. So here how the radiation or fields are calculation work. So with the help of that vectors, that is with respect to the Z, we can find mu by 4 pi Im dl e raised to the exponential form. Also we can find how we can obtain the HR, that is in the magnetic field, how the radius can be calculated, how the that is in the spherical coordinate r theta phi, that also calculated in the magnetic field. If there is a circular form radiation is going on, so here will be the 0, 0. Here will be the 1 by 1 by 4 pi into Im into dl sine of theta e raised to exponential form is mentioned here with respect to the current that is mentioned. So in this way, the electric field, magnetic field calculation can be do with the help of whether we are having the what you can say, the whether the Cartesian, the cylindrical or the spherical coordinate system. But if you talk about the in the space, so definitely that will be your the spherical coordinate system, and we need to take care about the three components r theta, r phi theta, r theta phi likewise, and we need to calculate the er theta e phi of that expression. and you can substitute in formula and you can calculate the unknown parameter. Likewise in the magnetic and the electric field, approximate the dimensions, how the beta propagation constant can be calculated, how the radius can obtain the expressions. These all these are the basic, that is IMDL sine of theta e raised to the power of this. So in this way, the zone of radiation is nothing but how the sources are coming, how the alignments are coming here, how the antennas are placed, transmitting and the receiving antennas are placed, how how the planes are coming here, how the lights is emitting, how the plane views are here, how they are radiating, how the wave will be on the surfaces, how the wave surface and the surfaces are there, how the spherical waves are coming here at the reflector. Okay, that is how we can get all these things here at the end side, the emitting side, with the help of the spherical waves. So this way, zone of radiation is nothing but again the densite be what we can say the zone of right. These are the different countries and they are offering the wavelengths, how they are differing the quasi is how they are fluctuating, how they are coming in the decorous decreasing form in the 1 by r square in the fluctuating and the quasi statement, how the wavelength is coming, that is mentioned here. How the Hertzian a dipole, because dipole in the two section they are dividing the upper portion and bottom portion with the positive charge and negative charge, that is a d will be equals to d by 2 d by plus d by 2. So at the one side plus of charge, at the other side minus of charge, we can find the dipoles of that. And what is that the laws, with the help of that we are interested to find out that the dipoles are nothing but Hertzian's dipole radiation. So in this way, the magnetic and electric, how the radiations are going on in the spherical, see here the difference, how the 30 20 10, how the 0 degrees are changing, how the current is flowing in each and every circle, how they are forming. So that is mentioned, how the electric and magnetic fields are here, how they are coming, how we can write that expression of 1 by 2 lambda r 1 by 2 lambda here, lambda r in this case, that is in the form of the j. If you're writing for the magnetic field, h is equals to that r of t, h is equals to r of t. So j by divided by 2 lambda r. In this way, you can write the expression for the magnetic as well as the electric field in the field space. This is one of the propagation, that is nothing but your the what we can say far field propagation, returning to the harmonic equation in the case of your the homogeneous and isotopic media containing the primary sources. At that time, you need to write the expression for that, that is electric as well as the magnetic. See here, this root of E can be find, or mod of E you can find as a minus j of omega mu h. If divergence of D, you can find divergence of B also you can find. In this way, you can find this propagation of equation. Also, we can write how the del of E, how the del of H already we have done in the uniform plane view. Also, how the minus epsilon mu dou square E by dou t square, dou square H by dou t square. That was possible. How the propagation in the direction of any one particular direction can be calculated. That is nothing but dou square E by dou z square minus epsilon mu. That is mentioned here. So in this way, these are the expression by which you can find not only the velocity of propagation, that is C here, V is equals to 1 by root of epsilon mu 0 epsilon 0, that is here. Already we have calculated my numerical on that. How we can write the expression in terms of the electric and the magnetic field with respect to Z and the T. The Z is a direction and time period T. In this way, the electric, as you see here, the electric field, see here the magnetic field, see here the exponential form on the both the side, how the omega t minus kz can be calculated. How I can find that k, that is k is equals to omega by v, the k is also equals to 2 pi by lambda, again omega into root of epsilon mu. That in one of the numerical in the morning session also we have seen that one, how we can calculate the constant parameter, how we can write the expression, how we can find the eta intrinsic impedance, that is mod E mod h is equals to root of mu by epsilon is nothing but my eta, that is nothing but 377 is like with the spherical wave planes, the point and the charges, how they can come, how they are needed. That is mentioned, how the far field is laid, that is E with respect at a particular radius, how I can find my electric field, how I can find my magnetic field, what will be my at a free space electric field with respect to the radius, and how I can write my expression for the what we can say exponential component by considering the propagation constant and all. That is mentioned here. So here the plane wave approximation, how the wave can be travel in the plane wave. This is the wave front, this is the propagation for direction, how the electric as well as this magnetic field, how the current will be start to flow if they are the wave will be propagating and perpendicular to that plane. So what will happen? How we can find all these things solution with the help of the Maxwell's equation. Okay, all these things we are finding with the help of Maxwell equation. That's why E is equals to E0 cos of omega t minus beta z of dz. We have simplified numerical on that. How we can carry the power if you talk P is equals to E cross of H. So we need to take care here the X, Y, Z are the Cartesian coordinate system in that how the E and the how the H we are taking in this way the what you can say the power or the pointing vector with the help of that 1 by 2 E cross of H we can calculate the vector